Hello, grade 12s. Welcome back to the channel. So in today's lesson, we're going to be looking at parabola functions, all the things that you need to know under the parabola function. So without any further ado, let's just get right down to business. Okay, so we have some lesson objectives. So these are the things that you should know by the end of the lesson. So you should be able to determine the equation of a parabola function. You should be able to calculate the coordinates of the intercept with the axis. You should be able to calculate the axis of symmetry. Also calculate the turning points, which is your minimum or your maximum value of the graph. And you should be at a point whereby you are able to sketch the parabola graph. Also be able to comment on the domain and range of the parabola graph. Then you should be able to determine the x-coordinate for which the graph is increasing or decreasing, determine the x-coordinate for which the graph is above or below the x-axis. All this will be covered during the lesson. Okay, so to start with some necessary basics for the parabola functions, this is what you should know, right? We have the standard form equation. And then for that, we know that y is equals to ax squared plus bx plus c, right? And then followed by the turning point form of the equation, which can be written as y is equals to a, and then x minus p, that square plus q. Then we also have the root form of the equation, which is y is equals to a, and then x minus x1, x minus x2. Now, there are conditions for using the turning point form and the root form equation, right? Most of the time, we focus on the turning point form if we are given the coordinates of the turning point, right? Which the coordinates of the turning point are usually what we substitute into P and Q, right? So your turning point, your x coordinate of the turning point is P, and then your y coordinate of the turning point is Q, right? So we need to have the coordinates of the turning point here. And then we can also have any other point that is given on the graph, any other point. Then what are the conditions for using the root form? For the root form, we need the intercept, right? The intercept. So most of the time you find that it is two x-intercepts that are given. So let me be specific, the x-intercepts. So the x-intercepts are your roots. So you need the x-intercept, which are what we call the root. And then we can also be given any other point. So this any other point, most of the time you can find that it is the y-intercept. So let me say mostly the y-intercept in a lot of questions. Okay, so we have the turning point form and the root form. Then this is all a matter of having to change either the turning point form or the root form back into the standard form. So most of the time when they want you to solve those questions, they want you to end up writing this in terms of the standard form. So when they say find the equation of the parabola graph, they mostly want you to calculate it in terms of the standard form, unless maybe stated otherwise. Sometimes they do say that you must leave your answer in this format, so you can just leave it in turning point form. But in most of the cases, they need it in standard form. Okay, so these are the formulas that you'll be using there in order to calculate or in order to determine the equation of the parabola function, right? Now, other things that you should know is that your A there is simply determines the wideness and the shape of the graph, right? So what do we mean by the shape of the graph? If you find that your A is less than 0, meaning that your A is negative, most of the time you will observe that your graph will be like this. We say this is a concave down parabola graph. This is concave down. And then a concave down graph is characterized by having a maximum value at the turning point. So the value that we'll be having here is the turning point, which is made out of the axis of symmetry. So you will catch up with the terminology. Then it is made out of the x coordinate of the turning point, which is your axis of symmetry, and then also the y coordinate of the turning point, which is your turning point right there. Then if your A is greater than 0, meaning that your A is positive, you will observe that the shape of the graph will be like this, right? The shape of the graph will be like this. And then we say this is concave up. And then it is characterized by having a minimum value as the turning point. So it is very crucial that you understand that if your A is negative, we have concave down graph, which looks like this, and then it has a maximum value. If your A is positive, then we have a concave up graph, which has a minimum value and will end up looking like that. So at your school, they usually say this is a smiling graph, and then they say this is a frowning graph. So this is a frown and this is a smile, right? But then the actual names are concave up for a smiling graph and concave down for a frowning graph, right? So these are all the things that you need to observe. When we are talking about the wideness, you will observe that if your A becomes bigger, so if your A is bigger, then what you observe is that if in the wideness, so if your A value becomes bigger, then there is greater wideness, right? But then the more your A becomes a smaller value here, even the wideness of the graph becomes very small, right? Okay, so let's proceed. So once you know these basics, then it's time for us to just try to do something. So, okay, let's say we want to, the first thing that we want to focus on is determining the equation of the parabola. The equation of the parabola function. Right. So to determine the equation of the parabola function, these are the things that we should observe. Remember, I did speak about the turning point form and also the root form. So in this case here, let's start with the root form. Right. Now, what are the conditions for the root form? We said the conditions for the root form, you need to ensure that you are given the x-intercepts. Right. Now, you will find that obviously, because as we can see here, your graph most of the time will intersect twice here. That means you'll be given two x-intercepts. So these are your roots. And then you also have to have any other point. And then we said that any other point in most of the cases, it will be your y. It will be your y-intercept. Okay, the x-intercept that we are given here are -2 and +4. Remember, an x-intercept is the one that intersects with the x-axis, right? So we can write this in coordinates and say we have -2 is to 0, and then we also have 4 is to 0. Now, what is the any other point? The any other point can be the y-intercept, which we can observe it from here. It is -8. Writing it as coordinates, we have 0 is to -8. Remember, whenever we are writing coordinates, they are in the form of x is to y. You start with the x coordinate and then the y coordinate. Okay, so let's say now you are given a situation like this, and you want to determine the equation of the parabola function. What is it that you will do? So number one, you will start with writing the equation, right? Which is your root form equation, y is equals to a, and then x minus x1, and then x minus x2. Now, understand this. The first thing that you should do is to calculate. So step number one, calculate the value of a. Calculate the value of a. That's step number one. Calculate the value of a. So what you want to do here is that this any other point here, you are going to substitute it into your x and y, right? And then this coordinates that we are seeing here, or the intercept, you are going to make them your x1 and your x2. Understand that. So the roots are your x1 and x2. This is where you're going to be substituting the root. For y and x, you want to be substituting the any other point. So you substitute the x coordinate and also the y coordinate. So let's do it. That means where there is y, I will put -8. and then I do not have the value of A. That's what I'm trying to calculate. But what is the x coordinate of the any other point? It's 0. So I have 0, and then check. The x1 is -2. I already have minus here. So you understand it. If it's minus, then it's going to be, or let me just do it like this, minus, and then -2, so that it's not confusing. So I'm just going to substitute it like that. And then here I have 0, and then -4. Now, obviously, you do understand this is -8, and then A, the 0 minus it's 0 plus 2, right? Because negative times negative is positive. So 0 plus 2, that's going to be 2. And then 0 minus 4, that's going to be -4, right? Now, obviously, you need to multiply this. So I have -8, and then 2 times -4, that's -8A. Then divide both sides by -8. Then my A is going to end up being 1, right? Now that I have the value of A, so I'm done with step number 1. I have the value of A. Now, second step is to substitute back into that equation. So step number 2, step 2, substitute back to the equation, right? So, but then now when you are substituting, you need to be careful. You are now only substituting the roots and the value of A. So substitute back into the equation only the root and the value of A that you have got. So this is y is equals to, what's your value of A? It's 1. And then you leave the x and y as it is. So you substitute the root here, it was -2, so it's going to be +2, right? And then x -4. Now at this point, you can try to FOIL in here so that you end up with the standard form equation. What's x multiplied by x? Obviously, 1 multiplied by all of this will just end up being x plus 2. So now I have x plus x is x squared, right? So this is what I'm doing, foiling, and then foiling. So what's x multiplied by that? It's -4x. What's 2 multiplied by this? That's 2x. What's 2 multiplied by that? It's -8. So this is y is equals to x squared, -4x plus 2x, that's -2x, and then -8. And just like that, I have the equation. And then also another important thing, it is very important that you understand that in this equation, y is equals to ax squared plus bx plus c. The c here is actually the y-intercept. As you can see here, the y-intercept is -8, and on that value there, or on that position, we have -8. So the value that you are going to see for the letter c here is always represents your y-intercept, right? So let's suppose that you are given, for example, y is equals to 3x squared plus 2x plus 1. And then they ask you, what is the value of the y-intercept? The value of the y-intercept is right there. So the constant value there always represents the y-intercept. Okay, so now you have seen how we calculate the equation. But then, okay, let's try another example. Remember, the purpose of these videos is for you to master the concept, right? So by the end of the lesson, you should be able to answer all these questions. You should be confident about answering these questions here. Okay, so again, we're still going to use the root form, right? We're still going to use the root form. So we must make sure that we have both intercepts. We have 2 here. And then obviously here, looking at the interval, we understand that we are supposed to have -3 here. This is -2. And then here we have -4 in between. We have -3. So our intercepts are, let me just say x is 2, and also x is equals to -3. Okay, then any other point, we can see that we have an intercept there at 2, 4, 6. So this will be written as what? 0 is to 6. So this is the any other point. We have the roots, and then we have the any other point. Any other point, right? Again, we go y is equals to a, bracket x minus x1, and then x minus x2, right? So the first thing that we should do, again, we first calculate the value of a. Calculate value of a. So y and x, we are going to substitute this. What is our y value? It's 6. And then we don't know the a value. For x, we're going to put 0 here, but then x1, we'll take this as x1, and then we'll take this as x2, right? And then this is going to be 0. Since it's -3, it's 0 minus minus, so that's 0 plus 3. Now you understand the drill. So this is 0 minus 2 from here. This is 6, and then we have 0 plus 3. That's just 3. 0 minus 2, that's -2. And then this is 6. 3 times -2, that's -6a. Divide both sides by -6. Then our a value will be -1. So we can say this time around our a value is negative. Now, I also want you to pay attention. Note that because our a is less than 0, it is negative. What is happening to our graph? It is concave down. It's a frowning graph. But with the one we were doing previously here, if we were just to go back, we found our a as a positive, and then what happened to our graph? Our graph was concave up, right? So now you understand the whole idea. So if the a is negative, then you have a concave down graph. If the a is positive, you have a concave up graph. Now at this point, if you have your value of a, then you'd have to substitute back into that equation. So y is equals to a, x minus x1, and then x minus x2. But then this time around, we are only substituting the value of a and the roots. So substitute the value of a and roots back to the equation. Back to equation, right? So make sure that you note the steps, guys. This is y is equals to -1, and then x plus 3, and then we have here x minus 2, right? Now, obviously, you're going to have to foil what's in this brackets here. So you have y is equals to -1. Because this is a negative, you need to leave it there. And then you continue foiling here. This is going to be x squared. And then x multiplied by this, that's -2x. This multiplied by that, that's 3x. And then we have 3 multiplied by that, that's -6, right? So now we have y is equals to -1. So I'm keeping this inside the bracket because I have a negative outside. So this is x squared. And then here we will have positive x and then -6. Now we need to multiply inside with this -1. So it's going to be -x squared, -x, but negative and negative, it's positive. Again, we can see this value here. +6 happens to be the y-intercept. We can see that the value for c here represents the y-intercept, where the graph intersects at the y-axis, right? So, and then just like that, we have our equation. We have our equation. So I'm pretty sure that now you understand how to find the equation if you are given the roots and also any other point, right? Okay, let's proceed. Okay, now still on finding the equation, but this time around, let's focus on the turning point form. So the turning point form. So TP. Okay, so in this case here, we said with the turning point form, we need to know the coordinates. We need to know the coordinates of the turning point, which the coordinates of the turning point will be represented by the P and Q, right? And then you also have to have any other point. Now, the any other point that we normally use is the y-intercept. Not all the time, but in most of the cases, it's the y-intercept. Now, you can see that if we were to use the intercepts here, we do not really know the intercepts. As you can see, it is not exactly cutting at -1, and it's not exactly cutting at +3. So it is impossible for us to use the x-intercept. But then it is possible for us to use the turning point, because as we can see here, this is the x coordinate of the turning point, and right here, this will be the y coordinate of the turning point. So this here is supposed to be -7, looking at the interval. So that means your turning point here is actually +1, is to negative 7, right? So those are your turning points. So in most of the cases in your question paper, they will just be given like this right here. So they will be given to you. So this is your turning point. Now, what do we do? If we want to calculate for this one, this is how we approach this question. We have y is equals to a, and then x minus p, and then square plus q. So the first thing that you're going to do is you want to write that equation for the turning point. Now, the any other point that we are using is the y-intercept. We can see the y-intercept right here, and then looking at the interval, we can tell that the y-intercept needs to be negative 5. Now, writing the y-intercept in coordinate form is going to be 0 is to negative 5. So this becomes our y-intercept, which is the any other point. Again, what you need to note, this is your x, and then this is your y. This is where you're going to substitute. For your y, you're going to substitute the negative 5. Remember, the first thing, even with this one, the first thing that you should do is to calculate the value of a. Calculate the value of a. It does not change. Then you have a here. For your x, you're going to substitute the 0. And then minus, remember I said the turning point is represented by P and Q, right? So where there is P, that's where you have the X coordinate of the turning point. Where there is Q, that's where you have the Y coordinate of the turning point. So I have 0 minus 1 and then square. So substitute it exactly as it is. Then the Q here is negative 7. So what you normally do with this question is that first you can take this and transpose it over to this side. So you will have negative 5 and then plus 7. So this is what we're going to have, negative 5 plus 7. And then here you have a. Obviously, if you punch this into your calculator and then you square it, it's still going to be 1. So negative 5 plus 7, that's a positive 2. So now you have a is equals to 2. Now that you have calculated your a value, it's now time for you to calculate the equation, right? So now we need to determine the equation. To determine the equation, this is what you're going to do. Remember, now you have the value of a. Number 2 is you're going to substitute value of a, p, and q back into the equation. So which equation? That turning point equation. So we have y is equals to, what's your a value? It's 2. And then now you are no longer substituting for y and x. So this is x minus 1, square that, and then minus 7. And then what you're going to do is, obviously, we can see that we need to expand this because of the square here. So this is 2, x minus 1, x minus 1, and then minus 7. So what you are supposed to do here is then FOIL inside here. So this is x times x is x squared, and then x times that, that's negative x. And then also this one is negative x. So all in all, we're going to have negative 2x. Negative 1 times negative 1, that's positive 1, and then minus 7. At this point, you can then multiply inside by this 2 inside the brackets here. So this is 2 times that, it's 2x squared. 2 times this, negative 4x. 2 times 1, that's a positive 2, and then minus 7. Now you have y is equals to 2x squared minus 4x. The 2 minus 7 will give us minus 5. And then as we can see, again, the negative 5 happens to be the y-intercept right there. Okay, so that's how you were supposed to tackle this question here. So as we can see, again, we have successfully landed this from the turning point form into the standard form, right? So this equation is in the form of y is equals to ax squared plus bx plus c, where your a is 2, your b is negative 4, and then your c is negative 5, which happens to be the y-intercept. Okay, so awesome. That's how you solve these questions. Now let's see another one, right? Still on that. For that. Okay, still on the turning point form. Let's look at another way to calculate this. So still on TP form, we are given, again here, we cannot take the x-intercepts because as you can see, it is not exactly cutting at +1 and it is not exactly cutting at -3. So it is impossible for us to pinpoint the x-intercept, but then it is possible for us to pinpoint the turning point. So it's -1 is to what? +9, right? According to our graph there. So our turning point is -1 is to +9. Okay, so we have the turning point. Any other point we are going to use the y-intercept here, which happens to be 7 according to the graph here. So we have 0 is to 7. So again, we're going to write y is equals to a, and then x minus p square plus q. So for y and x, we substitute any other point. Y is 7, and then we are looking for the value of a. Remember, first calculate value of a. Calculate value of a. So we have 0, and then because now we have minus, and then this is also -1. This is minus multiplied by another negative. It's going to be +1, and then square. So I hope you understand that. Then the q here is +7. So I'm just going to put, no, it's not +7. It's actually 9. Pardon me for that. Then what we do is we take the 9, transpose it over to the side. That's 7 minus 9. And then here we have a. If you just square this, it's just going to be 1. Now 7 minus 9 will give me -2. So your a is equals to -2. Now again, we can see the observation. When our a is negative, we have a concave down graph. When our a is positive, we have a concave up graph. Now that you have the value of a, you can then find the equation. So this is y is equals to -2. And then x, remember number 2, you substitute value of a, p, and q back into the equation. So this is x +1 square plus 9. And then what do? First expand this bracket. This is x +1, and then x +1, and then +9. And then what do? You FOIL here. X times x is x squared. X times 1 is x, and then 1 times x is x. So we're going to have 2x as our middle term. 1 multiplied by 1 is 1. And then +9 like this. So this is y. Now you can multiply inside with the 2. That's -2x squared minus 4x, and then -2 plus 9. And then our equation is -2x squared minus 4x, and then plus 7. And again, as you can see, the 7 is the y-intercept. The value of c represents the y-intercept. And nice, that's how you calculate this. So I hope now you understand how to find the equation. Most of the time, both in grade 10, both in grade 11 and grade 12, you'll find that this is mostly the first question that they ask you to calculate to find the equation. So in grade 12, they can be smart about it and just say, show that a is equals to -2, b is equals to -4, and c is equals to 7. Do not be alarmed by this. This is also another way to say determine the equation. This is another way to say determine the equation of the parabola function. If they just say show that a is -2, b is what. So whatever value that they will be asking you to calculate. So basically, after finding the equation, then you will be able to see that based on the standard form equation here, your a needs to be the -2, your b needs to be the -4, and then your c needs to be the 7. Okay, so let's proceed now. Let's proceed. Okay, and then let's get to business. So with these questions here, these are the things that I want us to go through, right? So we have now an equation, and from this equation, I want us to, number 1, be able to calculate, so determine the x and y intercepts, right? So first, let's determine the x and y intercepts. Let's see how to calculate that. So in order to find the x-intercept, you have seen from the video that I've made previously, in order to calculate the x-intercept, you need to always know that your y needs to be equal to 0, right? Now, this means that if I want to calculate here, I will simply say x squared plus 4x minus 5, and then just equate it to 0. At this point, I only need to do what? Factorize here. So this is going to be x and then plus 5 and then x minus 1 is equals to 0. So if you can't factorize, remember, you still have the quadratic formula. At this point, you should know how to factorize, but then it is not a train smash if you don't know how to factorize. Simply just use your quadratic formula, and then you'll find your x values. So this is x is equals to -5, and x is equals to 1, right? Now, for someone who used the quadratic formula, this is -b plus minus, and then b squared minus 4ac over 2a. So all you have to note here is that your a value is the coefficient of x squared, which is 1. Your b value is the coefficient of x, which is 4. And then your c value is the constant, which is -5. Then you simply just have to substitute in here. Now, you know that your calculator, you start by saying plus, and then you come back and add it, you say minus. So when you put this into your quadratic formula, you should be able to find the same exact answers. So now you get x is equals to -5 or x is equals to 1, right? So we need to say or. So x is equals to -5 or x is equals to 1. Okay, so this is how you'd be calculating your x-intercept, right? This is how you'll be calculating the x-intercept. If you want the y-intercept, it's just simple, guys. Remember, we've talked about this. This here represents the y-intercept. So if you're looking for the y-intercept, you just need to know y-intercept is when x is equals to 0. This is similar to just substituting 0 wherever you see x here. So obviously, this will be 0, this will be 0, your y is equals to -5. So for the y-intercept, you can just simply say y is equals to -5, because as you can see, it's right there. Now, sometimes they want you to write it in coordinates. So be careful. If the question says determine the coordinates of the x and y intercept, then you need to come here and say -5 is to 0. And then here, this is 1 is to 0. Then you need to write this one as 0 is to -5. If you see the word, determine the coordinates of the x and y intercept. So this is how you write those in coordinates. The x coordinate, it's that to 0. The y coordinate is 0 to that particular number. Okay, so number 1, you understand how to calculate the x and y intercept. Number 2, what they can ask you to calculate is, number 2, calculate the axis of symmetry. Note this. The question ever asks you to calculate the axis of symmetry, you need to understand what is the axis of symmetry and the formula that we use. So there's a special formula that we use to calculate the axis of symmetry. It is written as x is equals to -b over 2a. In grade 12, you'll be given this formula. Yes, I think it's there in the formula sheet, but then it's best that you know this formula and you memorize this formula. So what you do here is, from the point y is equals to ax squared plus bx plus c, you know that your a here is +1, your b is 4, and then your c is equals to -5. That's what you substitute into this equation. You simply say x is equals to what's b, so you just say negative from the equation, and then in bracket you put your value of b. And then this is 2, in bracket you put your value of a. And then simply just punch the calculator from here. This is -4 divided by 2, which will give you -2. And just like that, voila, you have found your axis of symmetry. So this can be just a mark or 2, right? So you have calculated the axis of symmetry. But then the axis of symmetry goes hand in hand with the turning point, right? So after the axis of symmetry. So sometimes they can just say calculate the turning point. You cannot find the turning point without the axis of symmetry. So number 3, calculate the turning point. So basically what you do if you want to calculate the turning point is that you need to have the x coordinate of the axis of symmetry, right? You need to have the axis of symmetry, which forms this axis of symmetry is actually the x coordinate of the turning point. This is the x coordinate of turning point. So what you do is if you want to find the turning point, the y coordinate of the turning point, you simply just need to substitute the x coordinate back into this equation. So where there is x, now you have to put that same value that you calculated. So it's just easy like that. So provided that the question was just saying calculate the turning point, and then it was about 4 marks, then you needed to start here and then calculate the turning point. So -2 squared plus 4, and then -2 minus 5. So we are getting -9, right? So that means our turning point, writing it in coordinates, it's going to be -2 is to -9. And then just like that, you are done, right? So this is how we calculate the axis of symmetry and also the turning point. Okay, and now for number 4, we should be able to sketch the graph. Right, when it comes to sketching the parabola graph, you need to have the intercept with the axis. So most of the time they will say sketch the graph and clearly show the intercept with the axis. So which is your x-intercept and your y-intercept. And then they will also say you must show the coordinates of the turning point. The coordinates of the turning point, and then you must also know the shape. Right, so these are the things that are very necessary when it comes to sketching the graph. So the intercept with the axis, the coordinates of the turning point, and the shape. The shape, remember, it is determined by your a value here. So you want to know whether your a is less than 0. So the shape will be like this. Or if your a is greater than 0, whereby your shape will be like this. So this is if your a is negative, and this is if your a is positive. Now, looking at what we have here, we can see that the a is positive. So we know that this is the kind of shape that we should have. So now when it comes to sketching, let's see how the sketch would actually look like. So I have already sketched it. So these are the things that you'd have to show there. Remember, we did calculate our x-intercepts and we found that it was +1 and also -5. So you show these two intercepts here, the x-intercept. And then you also calculated the y-intercept, of which we can even see it from here. It's -5. So that means the graph intersects with the y-axis at -5. And then also again here, the shape, because of the a being positive, we can see it's concave up, but then what is the turning point? We can pinpoint it to -2 is to -9 as we have calculated. So this is the shape that we have there, right? And then that's how you actually sketch. Okay, so when you are done sketching, obviously you should answer questions on the domain and range. Now, I did mention that when it comes to the domain of any parabola graph, the domain of any parabola graph is always x element of real numbers. Do not be confused. Always the domain for any parabola graph is x element of real numbers. But when it comes to the range, remember the range depends on whether your a is greater than 0, positive, or your a is less than 0, negative. Now that our a is positive, we know that this starts from a minimum value all the way up to infinite. So when you have to write the range, you have to say when y is greater or equal to, starting from, because the graph here starts to exist. Remember, when we are talking about the range, we are saying where does the graph exist in terms of the y coordinate, a set of all possible y coordinates. Then as we can see here, this is your graph existing all the way from -9 going upward. So how do we represent that in terms of the interval? We'll say when y is greater or equal to -9. Or if you prefer the set builder notation, you will say when y is an element starting from square bracket -9 all the way to positive infinity and then round bracket. The reason we are putting round bracket for infinity is because infinity is not a specific value, so we wouldn't know what infinity is, right? So this is why element -9 all the way to positive infinity. So these are the two ways in which you can write that. If you prefer this, you can just go with that. If you prefer this notation, then you can write it like that. But then that's your domain and range. Okay, so another question that we might have to answer is this here. So give the values of x. So give the values of x for which the graph is increasing, right? Give the values of x for which the graph is increasing. Where do we see the graph increasing? Remember, when we answer this question, our point of reference is always the what? The axis of symmetry, right? So in order to answer questions on increasing or decreasing, we have to actually look at the axis of symmetry. So from the axis of symmetry, remember, this represents where the graph will turn, right? So at this point, going all the way to that direction, we can see that the graph is increasing. So if you can just check here. So what is happening to the graph? So as the x values increase, the y values are also increasing. So we'll say the graph actually increases when x is greater than -2. Right. But then where is it decreasing? Where is it decreasing? Obviously, it has to decrease when x is less than. So if we can check here now, if we can just highlight this part here. Let's highlight here. What is happening to the graph before it gets to -2 here? The graph was decreasing. So as we are increasing in x values, what is happening to the y values? They are decreasing. So this is actually decreasing when x is less than -2. Right. So the values of x for which the graph is increasing is starting from -2 going to that direction. The values for which the graph is decreasing, it's that direction from -2 going back to that direction. So we say when x is less than. So you can actually see with where the inequality signs are facing. If it's going to that direction, we'll say greater than. If it's going to that direction, we'll say less than. Right. So that's basically how you answer those questions. And then also another typical question that you might have to expect, they might ask you, let's assume that this equation or this parabola function is f of x. So they will say, give the values of x for which f of x is greater than 0. Now, remember, I said the interpretation of this is that we must give the values of x for which the graph is above the x-axis. Right. So you have to understand mathematical language in order to successfully answer these questions. So for where f of x is greater than 0, when we decipher this, it means where the graph is above the x-axis. Where do we see the graph being above the x-axis? So let's do it like this. If you can check here, we can see that the graph is above the x-axis at this point here, and then also above the x-axis just like this here. So that means for values where we can see that it is above the x-axis, we'll say it's when x is less than, so from -5 here, going to that direction. So when x is less than -5, or starting from this value here, which is +1, going to that direction, or when x is greater than 1. So when we answer questions like this, where f of x is greater than 0, we have to base it on the x-intercept. So our references here becomes the x-intercept, right? Again, if they can say, give the values of x for which now f of x is less than 0. interpretation of this means where the graph is below the x-axis. Where is the graph below the x-axis? Now, if you can just check here, we can see that the graph is actually below the x-axis right here in between those two given values, in between those x-intercepts. So it's actually in between -5 to +1. But how do we write that in terms of the intervals here? We'll say x when x is greater than -5, but x is less than +1. So this is how you actually write it, and then this is how you read it. You say when x is greater than -5, but x is less than 1. When you read this one, it's more like you flip it over. So when x is greater than -5, but x is less than 1. Or if you just prefer to just write it like this, where x is an element from round bracket -5 all the way to +1. So the round bracket means that -5 and 1 are not part of the solution, right? So you will see it from the first video that I posted there, that the meaning of the round bracket and the square bracket. Okay, and then that's how you were supposed to actually tackle those questions right there. So because the purpose of the videos is just for mastery, we will look at yet another question and try to answer those very same questions, but then with a different equation. So now we have x squared minus 7x plus 10. Again, number one, let's start by calculating. So determine the coordinates of the intercepts. Right. Calculate the coordinates of the intercept. So your x-intercept and also your y-intercept. So starting with the x-intercept, we know that where our y is equals to 0. So we simply take this whole expression and then we have to equate it to 0. Now, it's your choice whether you know how to factorize this or you're simply just going to rely on your quadratic formula. But then if you were to factorize, we already know that's x here and then x here. We want to look for the factors of 10. When you multiply them, they're going to give you 10. When you add or subtract them, they're going to give you 7. So that's obviously 5 and 2. And then because of this one is positive here, we're going to have minus, minus. We have positive here, but a minus here. So that means we have to have a negative and a negative in between the brackets. Now, if you do not know the laws in to factorize, rather just stick to your quadratic formula. You still get full marks. Maybe they might penalize you if they really want you to factorize, but then it's just 1 mark that you would lose. So it's better than nothing. Then x is equals to 5 or x is equals to 2. And then writing it in coordinates, that's 5 is to 0. And then also 2 is to 0. When it comes to the y-intercept, we've already explained that the y-intercept, you simply just have to look at the constant there. So that means y is equals to 10 as your y-intercept. And then writing it in coordinates, it will be 0 is to 10. And just like that, you are done with finding the intercept, right? So it's just easy peasy like that. Then number 2, axis of symmetry. Then we've already discussed how we calculate the axis of symmetry. So we said there's a specific formula for that you will need to memorize, right? So this is x is equals to negative b over 2a. Remember, the more you get to use these formulas, the better, right? Because you would already know how to actually use them, and then they will be in your head. So your a value here is 1. Your b value is -7. So your a value is the coefficient of x squared, your b value is the coefficient of x, and then your c value is just a constant, your y-intercept. But then we don't actually need the c from here. Then what is b? We're going to have -7 over 2 and then 1 here, right? So punching this into your calculator, it's going to give you 7 over 2, which if you prefer to write it in decimals, 7 over 2 is going to give you 3.5. It doesn't matter whether you leave it as 7 over 2 or you write it as 3.5. So that's your axis of symmetry. But then we have mentioned that the axis of symmetry goes hand in hand with the coordinates of the turning point. So calculate coordinates of the turning point, right? So if you want to calculate the y coordinate of the turning point, we already know the x coordinate of the turning point represents, I mean, this axis of symmetry here represents the x coordinate of the turning point. So it's just a matter of coming here and then substituting the 7/2, that axis of symmetry where there is x, right? So with your calculator, you simply just do this. Then you grab your umshinwe ibalo and then simply punch all of this, right? So we have that. And then there we go. We have -9/4, right? Of which, if you are to simplify it, it's something like -2.25, right? Now, writing it in coordinates, that's going to be 7/2 is to -9/4, right? So basically, that's how you would be calculating this, right? So axis of symmetry and then also the coordinates of the turning point, we have calculated that. So indicate that this is your TP turning point. Okay, so now we proceed. Number 4 would have to sketch the graph. We have already mentioned when it comes to sketching the graph. So number 4, sketch the graph. You need to make sure that you clearly represent the intercept with the axis. So clearly represent the intercept with the axis, sort of for that. And then we have the coordinates, clearly represent the coordinates of the turning point. And then also make sure that you get the shape right. So get the shape right. Okay, so now let's just check how we were supposed to draw that. So there we go right there. This is the sketch that we were supposed to have. So it's intersecting here at 10. And then as we can see here, our x-intercept at 2 and 5 as we did calculate. And then the coordinates here, which are not clear to see, are the same coordinates that we got. That was your 7/2 is 2 -9/4. So we can predict it to be somewhere there, right? So these are your turning points. If they cannot be shown clearly like this, it is best for you to come and write them like this in coordinate form. But make sure that everything else can be seen here. If you have to plot here in order to really show that this is your y-intercept, and then also indicate plot here in order for us to see that this is your x-intercepts. Those are your x-intercepts, right? Okay, and then again, with the domain and range questions, so we have domain is x element of real numbers, as we already know. Then your range, because again, we have a concave up graph, it needs to start from here going all the way up. So we will write y greater or equal to -9/4. Note that when we are writing the range, we only focus on the y coordinate of the turning point. And when we are writing the range, it is always y greater or equal to the y coordinate of the turning point if the shape is like this, right? So basically, you can note this one down. When we are talking about the range on a concave up graph, it's y greater or equal to the y coordinate of the turning point. But then if the graph is concave down, then your range will be y less than or equal to the y coordinate of the turning point. So it is very crucial that you actually note this one down. So NB on that. So if you prefer this notation, again, it's y element of -9/4 all the way to positive infinity, then round bracket. So it's just a matter of preference, which one you understand best. Okay, and then again, we have the questions on where is it increasing or decreasing. So where is f of x increasing? So where is f of x increasing? So f of x is increasing from here all the way there. Remember, I said when they ask you increasing, decreasing question, you simply look at the axis of symmetry. So it's when x is greater than 7/2. But where is f of x decreasing? F of x obviously has to decrease going to that direction there. So it's decreasing there. You need to say when x is less than 7/2. And then we have other questions where is f of x greater than 0, of which we did decipher this. It means where is it above the x-axis? Where is it above the x-axis? So to answer that, where is it above the x-axis, we simply need to look at the intercept. When it comes to that, we look at the intercept. So from here, it's above, and then also here, it's above. And then how do you write this? You say when x is less than 2, or when x is greater than 5, because it happens before positive 2, and then it also happens after positive 5. So this is when x is less than 2, or when x is greater than 5. But where is f of x less than 0? Meaning, where is it below the x-axis? Where it is below the x-axis, we can see it's in between the given critical values, right? So we are going to say when x is greater than 2, but when x is less than 5, right? Or if you prefer to say x element of 2 all the way to positive 5, round bracket. So, okay, that's how you are supposed to answer those questions right there. So very nice, very nice. Let's continue. So even more on mastery of the topic, right? You need to walk out here having mastered everything here. So, okay, what if we are given something like this right now? This one looks a bit complicated, but then still we are going through the same questions. You need to calculate the intercept with the axis, right? So your x and y intercept. Then for x-intercept first, for x-intercept, we simply need to say y needs to be equal to 0. So this is 2x squared minus 3x minus 8 equal to 0. Now with this type of questions here, I prefer that you just simply use the quadratic formula because it can be a bit tricky to factorize, especially if you have a constant value, a coefficient here that is not a positive one, right? So if you have a constant that is greater than 1, it might be a bit of a challenge to actually factorize this. So you can actually go back to your old friend here, which is your quadratic formula, and just write x is equals to negative b plus minus, and then in square b 4ac. So you know the formula. It's also given in your formula sheet. So your a is equals to 2, your b is equals to negative 3, your c is equals to negative 8. And then you simply just come here, substitute everything exactly as it appears, right? Then your b negative 3 square, then 4, your a is 2, and then your c is negative 8, and then over 2, and then you have 2. Then it's just your calculator work from here on. Simply just punch all of this into your calculator. So there we go. So wait a bit, I'm still punching it into my calculator. So yeah, we are getting irrational values. X is equals to 2.89. So it is normal to get your answers in 2 decimal places here, or an irrational value, because as we can see, it's not possible to factorize that. And then also another value is x is equals to negative 1.39. So I'm just simply rounding these values to 2 decimal places, right? Okay, so these are your x-intercepts. So it is possible you can calculate and find values like this. And then when it comes to your y-intercept, you simply have to make x 0. Your y-intercept, still it doesn't change. It's the number that appears here. So your y-intercept is y is equals to negative 8. And then you can write it as 0 is to negative 8. This other ones, you can say 2.89 is to 0. And then here negative 1.39 is to 0. Right. So now you have calculated the intercept with the axis, the x intercept and also the y intercept. Okay. Then comes to the axis of symmetry. Number 2, axis of symmetry. Now we use our formula x is equals to negative b over 2a. Then we have seen that the b is negative 3. substitute there inside the bracket, then we have 2 and then 2 also here. Now, negative and negative is positive. 2 times 2, that's 4. So that means your axis of symmetry is 3 over 4. You can just simply leave it as a fraction like that, or if you prefer to just write it as a decimal, that's 0.75. So this becomes your axis of symmetry. And then you also need to calculate the coordinates of the turning point. Coordinate of the turning point. So we already know you have found the x coordinate of the turning point. So it's just a matter of coming here and then substituting that x value that you got there. Right. So there we go. Then minus 8. Then simply grab your calculator, punch all of that into your calculator. And then voila, we get a negative 73 over 8, which if you can SD that, it's about negative 9.125. So your turning points, you can write them as 3 over 4 is to negative 73 over 8, or you can say 0.75 is to negative 9.125. Now it's a matter of whether you prefer to leave it in fractions or you prefer to write it in decimal. Okay, so there we go with the coordinates of the turning point. And obviously after that, you need to know how to sketch, right? So for your sketch, we have found the intercept with the axis. We have found the intercept with the axis. We have found the coordinates of the turning point. And then we should also focus on the shape. Is our A greater than 0 or less than 0? Our A is greater than 0. It's positive. So that means the shape that we are expecting is a concave up graph, right? So let's see how we were actually supposed to draw that one. So the sketch for that is as follows. So we can see the intercepts there. So there we go with the intercept. Remember, we found rational values, which we did write in decimals. So it's something along those lines. That was your negative 1.39 here. And then here we had something like 2.89, right? So it makes sense. It makes sense. And then having to look at your turning point, we said it's 3 over 4 is to negative 73 over 8, right? So we can see here we got irrational values for the x-intercepts. Okay, so to answer questions on where is it increasing or decreasing, so where is f of x increasing? So f of x is increasing when x is greater than 3 over 4. Where is f of x decreasing? Again, we understand f of x is decreasing when x is less than 3 over 4 because we simply base it on the axis of symmetry here, right? So this point going to that direction, it's decreasing. And then this point going to that direction there, it's increasing. So the reference is the axis of symmetry. Then where is f of x greater than 0? Where is it above the x-axis? When x is less than negative 1.39, or when x is greater than 2.89. As we can see, the graph is increasing, right? I mean, the graph is above the x-axis at that point, above the x-axis. And then where is it below the x-axis, f of x less than 0? It has to be below the x-axis when x is greater than that negative 1.39, but less than that 2.89. Or you write it as x element, negative 1.39, and then is to 2.89. Okay, so those are your questions right there. Let's look at another one. So now we have something different here. It's y is equals to negative x squared minus x and then plus 6, right? As we can see, our a now is negative. So again, let's start by calculating. So calculate the intercept with the axis. So if we want the x-intercept, you have to make y 0. So this negative x squared minus x and then plus 6 equal to 0. Now, if we have this as a negative here, it is best that we start by dividing by -1 both sides in order that our a value here is positive. So I'm just going to divide by -1 throughout, and then this is going to be positive x squared plus positive x and then -6. 0 divided by -1 is still 0. Then from here, I can be able to factorize. Then to factorize this is simply x plus 3 and then x minus 2 equal to 0. If you can't factorize, you can still use your quadratic formula. So this is x is equals to -3 or x is equals to 2. In coordinate form, that's -3 is to 0 and also positive 2 is to 0. Now, when it comes to the y-intercept, that's where your x is 0. So your y-intercept is just simply y is equals to 6. In coordinate form, that 0 is to positive 6. Okay, nice. And then come to the axis of symmetry. Number 2, axis of symmetry. So when it comes to that, we simply say x is equals to -b over 2a. What's your b value? It's -1. And then what's your a value? It's -1. So negative and negative is positive. This will be negative here, so we will have -1 over 2, right? So this becomes your axis of symmetry. From the axis of symmetry, you should also be able to calculate the coordinates of the turning point. So we'll say coordinates of a turning point. So we'll say y. Where there is x now, we are substituting by that x coordinate there or that x value. So there we go. So make sure that you punch it exactly as it appears in your calculator. Do not allow any mistakes. Tan, taran, tan, tan. Okay, so we are getting 25 over 4. So your turning points are actually -1 over 2 is to 25 over 4. Now this can be written as -0.5 if you prefer it in decimal form. And then this is 6.25. So this actually helps. The decimals actually help in trying to sketch, right? Because when it comes to sketching, there is no way to find -1 over 2. Obviously, you need to know what is -0.5 in terms of the Cartesian plane. And you also need to know the 25 over 4 in terms of the Cartesian plane. So in terms of the Cartesian plane, it's 6.25. And then that's your turning point. So it is best sometimes to just write them in decimal form, especially if you have to sketch afterwards. So, okay, sketch, we already have the necessary coordinates or the necessary values to sketch. Then there we go. We have the intercepts here. So your intercepts were +2 and -3, as we can see. And then your turning points here were -1 over 2 is to 25 over 4, right? Or you can say there were a -0.5 is to 6.25. So if we write them in decimals, you see we are able to locate and predict that the value just needs to be a little bit above +6 there. Just a little bit above +6. That's where we have our turning point, right? And then again, a domain and range. With the domain, it's x element of real numbers. But right now, check our a value is less than 0, meaning that we have a concave down shape as we see. Now, this affects our range. That means the graph starts to exist from here all the way down, right? So above this point, we don't see the parabola graph. So that means in writing out our range, let's focus on the what? On the y value of the turning point. That will say when y needs to be less than or equal to 25 over 4. So now you get the whole difference. When it's concave down, you say y is less than or equal to the y coordinate of the turning point. When it's concave up, y is greater or equal to the y value of the turning point. Or if you have to write this now in terms of the set builder notation will say y element of check round bracket from negative infinity all the way to positive 25 over 4, and then square brackets. You get the whole idea, because this now starts all the way from down here and then goes all the way up there, right? It has a maximum value. So whenever we are writing this, it needs to start from the minimum value to the maximum value. We know range is mean to maximum, right? So from the minimum value, it's negative infinity all the way to positive 25 over 4, which is your maximum turning point. Okay, so nice. And then questions on this, where is your f of x increasing? So f of x increasing, we look at the axis of symmetry. So we can see that it is actually increasing before that axis of symmetry. It is actually now increasing before the axis of symmetry. So we need to say it is increasing when x is less than negative 1 over 2, right? Because it's actually increasing from here going all the way back, right? Remember? But then where is your f of x decreasing? Right. Now, this time around, it is decreasing when it's going in that direction, right? So the more you are increasing in x values, your y values decrease. But then here, the more you are decreasing in your x values, the y values increase. And then now we need to say f of x is decreasing when x is greater than 1 over 2, right? And then again, where is your f of x greater than 0? Meaning, where is it above the x-axis? Where is it above the x-axis? We can see that it's above the x-axis at this point here. This point here. Yes, in between these two critical values. So we'll say when x is greater than negative 3, but x is less than positive 2. Or you can write it in this notation, x element of negative 3 all the way to positive 2. But where is f of x less than 0? Meaning, where is it below the x-axis? Where is it below the x-axis? It is actually below the x-axis right at this point here. So below the x-axis here. So when your x is less than negative 3, or when x is greater than 2. So note that the reference is always your intercept here, your x-intercept. When it comes to this type of questions, your reference should always be the x-intercept. When it comes to decreasing or increasing, your reference should be the axis of symmetry, right? So make sure that you always note that. Okay, nice. Nice, 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 nice. Okay, now we have another fairly complicated equation here. Y is equals to negative 1 over 2x squared plus negative half x plus 1. So if you can just allow me to write it properly, half x squared, and then plus minus is just minus, and then half x plus 1. So we're still going to start by number 1, calculate the intercept with the axis. So again, nothing changes. Just because you have this infraction doesn't mean that the maths will change. You still do the very same thing. If you're looking for the x-intercept, make your y 0, right? So this is going to be half x squared minus half x and then plus 1 is equal to 0. Now, the one smart thing that you want to do here, you don't want to find yourself working with fractions, because fractions can be really, really complicated to deal with. So now you just want to multiply the left-hand side and the right-hand side by the denominator, right? So now, if you can check, the denominator is 2 here. So I can just multiply, because I also want to get rid of the negative here, I can just multiply both sides by negative 2. So multiply everything throughout by negative 2, also on the right-hand side. What you do on the left, you also have to do on the right. Now, when you multiply there, you will have what? Negative 2 times negative half, that's going to be positive x squared. And then negative 2 multiplied by negative half, that's going to be positive x. Then negative 2 multiplied by positive 1 there, it's negative 2. And then equal to 0 times negative 2 is still 0. Right. Then at this point here, you need to actually factorize this. So which will give you what? You'll say when you factorize, that's x plus 2 and then x minus 1 equal to 0. So this is x is equals to negative 2 or x is equals to 1. In coordinate form, you have negative 2 is to 0 and also positive 1 is to 0. Voila, done. So that's all you need to understand when it comes to this. You simply look at the number that will be on the denominator here and multiply it throughout by that number. If this was 3 over 4, I would multiply by 4 because the 4 here would be the denominator, right? So you simply multiply throughout by the denominator. If we have a negative, multiply throughout by the denominator and make it a negative here so that it makes this a positive. And then everything else also changes signs. Okay, when it comes to the y-intercept, also it does not change. That's where your x is 0. We can just substitute 0 here. We do agree that your y-intercept will be this value here. So y is equals to 1, which in coordinate form, you'll say it's 0 is to 1, right? So nice. So we have the intercept with the axis right there. And then number 2, we need to find the axis of symmetry. So for the axis of symmetry, again, we also know the formula x is equals to negative b over 2a. Your b value from here, that's your negative 1 over 2. And then your a value is negative 1 over 2. Then simply carefully punch this into your calculator. You need to carefully punch this into your calculator. Negative and negative will give you positive, so you have 1 over 2 up there. If you multiply this, this will give you negative 1, right? And then if you are to say half divided by negative 1, this is going to give you negative 1 over 2. So which will become your axis of symmetry. So in your calculator, you can also confirm and then just punch that into your calculator exactly as it appears. And then I believe it should give you the very same answer. I'm confirming. And then, yep, that's the value that we find there, negative 1 over 2. Okay, then we already know after the axis of symmetry, you need the coordinates of the turning point. So I'm doing the very same questions with different equations so that you are able to master this. When you get to the exam, you already know. And then simply just substitute where there is x, right? Then this is your umshinwe ibalo work, calculator work. All you have to do is just to make sure that you punch everything exactly as it appears. Right, make sure that you put that square there, the exponent of 2. Then there we go. When you punch that into your calculator, you get 9 over 8, positive 9 over 8. And then that means your turning points are negative 1 over 2 is 9 over 8, right? If you want to write in decimal form, that's negative 0.5 is to 1.125, right? So that you can be able to locate when you want to draw or sketch. So, okay, when it comes to the sketch, number 4, let's sketch. You already have the intercept with the axis, the coordinates of the turning point. So you can just go and sketch. So our intercepts, that's your negative 2 and also positive 1, check. And then your turning points, they became negative 0.5 is to 1.125. And then looking at where that is, it actually makes sense. It's just a little bit above positive 1, just a little bit above positive 1. That's where your turning point is. So correct. You clearly indicate the intercept with the axis, and then you also indicate the turning point. So where it intercepts with the axis is at 1. As you can see, the 1 is right here on this line. And then just above, that's where we have the turning point. So you will actually have a shape like this. And then again, discussing our domain in range. Domain is always X element of real numbers. But when it comes to the range, since now we have a concave down graph, we need to say when y is less than or equal to the y coordinate of the turning point, which is y less than or equal to that 1.125. Or if you wrote it in terms of the fraction, you'll say when y is less than or equal to 9/8. Now, if you prefer this notation, that's y is an element of round bracket negative infinity all the way. So from the minimum all the way to the maximum point, which is 9/8, and then you square bracket, right? So that's how you are supposed to deal with those questions right there. Then, okay, nice domain and range. That's how we write it. And then what about these questions here? So where is f of x increasing? Where is the graph increasing? So we can see once again here, we need to note that our point of reference becomes the axis of symmetry. Where is it increasing? It's before the axis of symmetry. So we'll say when x is less than -1/2 or -0.5. And then where is f of x decreasing? As we can see, after the axis of symmetry, what is happening to the graph? It is decreasing. So when x is greater than that axis of symmetry, -1/2. And then where is our f of x greater than 0, meaning above the x-axis? We can see that it is just in between the x-intercept. So when x is greater than -2, but x is less than +1, right? But then where is f of x less than 0? So meaning below the x-axis, we can see it's below the x-axis, from there going that direction, and then from here going that direction. So from here going this direction, and from here going that direction. So that means we will say when x is less than -2, or when x is greater than +1, right? So basically that's how you are supposed to write that. Remember, this also can be written as x element of -2 to +1. Okay, nice. So I hope everything makes sense. And then watch this video as many times as possible. Try to go back to this question. Try to actually answer these questions on your own with the same activities. You can just take the equations and try to go through those questions that we were trying to answer there, just to make sure that you understand everything. But then with all that being said, guys, ciao. See you on the next episode.